the world of data structures. Our today's topic is shortening. Two other shorts that we have left in a previous lecture. So today we are going to see about the quick short and the merge short. Hi, this is your instructor Janice Shah. So let's begin with today's outlines. Students, today first we are going to see about the divide and the conquer methodology. Okay. Then we'll see the quick short working method, then quick short algorithm, quick short example, then merge short working, its algorithm and example. So let's begin with the first terminology that is known as divide and conquer methodology. So students, the quick short and the merge short both are working on divide and conquer methodology. Why it is known as divide and conquer? So just imagine a situation that you have a vast problem or a big problem. Okay. So what you are going to do that you cannot solve it directly. You just need to divide that whole problem into small sub problems. Okay. Then identify the solution for the each and every problem, small sub problems. Then identify the solution for each and every sub problem, and then combine the whole solutions together. That becomes your final answer. So divide and conquer methodology is working for the same thing. So here we have the divide and conquer methodology where we need to divide the large problem into the smaller sub-problems. Then solve the small problems and conquer its solutions. That means the strategy that solving the large problems by breaking the problem into the smaller number of parts and combining its solutions together. That is known as divide and conquer method. So, the quick short and merge short are both the basic examples of the divide and conquer methodology. So, let's first begin with the quick short. So, the quick short, what to do in this? Okay. So, listen very carefully, students. Here in quick short, we are just going to split our array into two sub arrays. Okay. Where each and every element is in the left sub array is less than or equal to middle element, and the element which is on the right sub array is greater than the middle element. So splitting up the array into the two sub-array is based on the pivot. Okay. So what is the pivot? See, we are just splitting up the array after getting the pivot from the list. Okay. So the values which are on the left side of the pivot are smaller than the pivot, and the values which are on the right side of the pivot are greater than the pivot. Okay. So what we are going to do? See, here in this figure, first we have the whole list over here at the starting point of the list. We have P. P is known as pivot. So basically in quick short you can initialize pivot at any level. But for today's example, we are going to initialize pivot at the first position. So remember that we are just initializing pivot at the first position. Or we can say A of 0 index or A of low index. Fine. So we have the pivot over there. Okay. After finding out the pivot, our first task is to find out the pivot over there. Then just put the pivot in the middle of the list. Okay. So whatever the elements which are smaller than the pivot are there in the left side of the P, and greater than the pivot are on the right side of the P. Okay. Then you need to apply the quick short again on the left side and on the right side. Then again you need to find out the pivot. Then again divide the problem or list into the sub parts. Then apply quick short algorithm again. Fine. So you can go like this. So first we have the quick short steps. So what do we need to do over here, students? Here the first condition is while A of I is less than or equal to pivot. Suppose if A of I is less than or equal to pivot, then do I increment. Then increment I. Okay, just follow these three basic steps. That's enough for the quick short algorithm. Just remember three basic steps. The first step is if your A of I is less than or equal to pivot, then just increment I. Okay. Then A of j is greater than or equal to pivot, then decrement j. Okay. So at a one point, students, your I is not getting incremented, and at the one point your j is not getting incremented. So if your I becomes stop and j becomes stop, or we can say if I stops incrementing and j stops decrementing, then at that time you need to swap both A of I and A of j. That is the third condition. Next we have see, in some cases, if a j crosses I, if here it is I, here it is j, if j crosses I, then at that time you need to swap A of low and A of J. Fine. So once you swap A of low and A of J, that is the point where you need to fix up the position of a pivot element. Okay. So at that time the J position is fixed, and then you need to apply the partition from that point. So you need to divide your whole list into two parts where you swap A of J and A of low. So where to divide the list? Okay. So you need to divide the list from J position. So next we have first the quick short example. So here it is. See, here I have the values like 50, 30, 10, 90, then 80, 20, 40 and 70 degrees. Okay. So here the values are situated at the index from 0 to 7. Okay. So what you need to do is first you need to initialize your I and J. So how initialize I and J? See, according to the algorithm, the quick short example, the first I must be at 0th index. So I must be at low. Low that means first index. High that means last index. So J should be initialized at 7, or we can say high, and I should be initialized at low, or we can say 0. Fine. And our pivot is nothing but pivot is a of low. Pivot is a of low. That means pivot is where? Pivot is in with I. Okay, fine. So pivot contains the value of A of low. Fine. So I is at 50, J is at 7. That means I is low, J is at high position. Now just start your algorithm. Okay, what is the first rule? First you need to check whether my A of I is less than or equal to pivot or not. So here it is. My first step number 1. Here I am going to check with either my A of I is less than or equal to pivot. See, 50. A of I, that means 50. Pivot itself means 50. So students, 50 is less than or equal to 50? Yes or no? 50 is less than or equal to 50? Yes or no? Yes. So what you have to do is you just need to increment I. Increment I. So my I is getting incremented and it goes like this. Check the step number 2. Okay. So now I is pointing at 30. Fine. Now again you need to check whether my A of I is less than or equal to pivot or not. So is that so? Yes. Still 30 is less than or equal to 50. So you need to increment I again. So now my I will point at 10. So here it is. See, my I is point at 10. Fine. Now my I is at 10. Again you need to check the same condition. A of I is less than or equal to pivot or not. So 10 is less than or equal to 50. Yes. Again. So what you need to do is you just need to increment I pointer. So I am just incrementing my I value over there. Now my I is pointing at 90. I is pointing at 90. So just check it out. If A of I is less than or equal to 50, 90 is less than or equal to 50, condition false. So at that time you need to stop incrementing I. Okay. Now let's move towards the next condition. Next condition is for J. See students, first you need to apply the condition for I only. Once the I getting stopped, then apply for the J. Once the J getting stopped, then apply for the condition for I stop and J stop. Fine. So first I just apply for the condition for the I. My I is incrementing from 50 to 30, 30 to 10, 10 to 90. Now I becomes stop. So it's a turn for J. Okay. So here the A of J value is 70. Just check it out. 70 is greater than 50. Yes or no? 70 is greater than 50. Yes. So J should be decremented. So J is go at 40. See like this. Fine. Now again check it out. Is 40 is greater than 50? Yes or no? 40 is greater than or equal to 50. Yes or no? No. So now here at this position my J is stopped. Okay. So now J is not going to be increment more. So what happens over here? I is stopped. Yes. J is stopped. Yes again. So what happens over here? I is stopped. Yes. J is stopped. Yes again. So what you need to do is you just need to apply the swap function over here. Swapping of which values? Swapping of 90 and 40. Swapping of 90 and 40. So 90 will take the place of 40 and 40 will take the place of 90. It goes like this. See, I have just highlighted with the yellow color so you can get the better idea that how the 40 and 90 will swap each other. Fine. So after swapping 40 and 90, you need to do increment and decrement of I and J respectively again and again. So here again let's start your cycle where you are going to find out whether my A of I is less than or equal to pivot or not. So here it is, 40 is less than or equal to 50. Yes, that means increment I. Next we have C, increment I. So I is at 80. Okay. So next we have 80 is less than or equal to 50. No. So I is stopped. Now it's done for J. So apply 90 is greater than or equal to 50. Yes. So J decremented. J decremented. So it goes like this. Then 20 is greater than or equal to 50. Yes or no? No. So what you need to do is here your J has been stopped. Okay. So J is stopped. I is also stopped. What you need to do is you just need to swap I and J both. See, here we are going to swap the positions. No. We are going to swap the values of A of I and A of J. Fine. So here it is. After swapping the values, this is my array. Okay. So 20 and 80 are there. Okay. Then what you need to do is again start with the I. So 20 is less than or equal to I. Condition true. So I is getting incremented. Next. Check out. 80 is less than or equal to 50. No. That means condition false. So I has been stopped. Now check out for the J whether 80 is greater than or equal to 50. Condition is true. So here J is decremented again. So now at this step J crosses I. See, check out the figure. J crosses I. J is at 20, I is at 80. So we can say J crosses I. So as the J crosses I, students, what you need to do is you just need to swap A of low and A of J. So here A of low, that means our pivot element, that is 50. So you need to swap 50 and 20, both of them. So here this becomes my new figure where the new answer is 20, 30, 10, 40 and 50, 80, 90 and 70. See, I am just highlighting 50 over there just because now after swapping with the pivot element or after swapping when the J crosses I, after swapping this 50 becomes fixed at its position. Okay. So here 50 is fixed. So what to do? You just need to divide this list from this part. Okay. So now just listen it carefully. Now the new position for applying the quickshot algorithm is becomes from 0 to 3 and 5 to 7. The indexes should be from 0 to 3 and 5 to 7. It should be the indexes for quickshot algorithms. So here it is. See, now I need to apply my quickshot algorithm on 0 to 3 and 5 to 7 like this. So here now my new I, low, pivot and high I am just applying over there. Okay. So we have two different lists with us. First on the left part we have 20, 30, 10, 40. On the right part we have 80, 90 and 70. So I am going to apply the quickshot algorithm on both of them simultaneously in this example. Okay. So what I am going to do is how it works. Let's check it out. The first we have I is at the first position, that means at low. Okay. Pivot is at low. J is at high. So for the left sub list, our high becomes 40. So J must be at 40. Okay. On the right sub list we have I at 80, low at 80, pivot at 80 and the high and J at 70. Fine. So what to do next? Next, let's apply the same algorithm as previous. If I'm talking about the left sub list, then 20 is less than or equal to 20. So I will be incremented. On the right side, 80 less than or equal to 80. So I will be incremented. So on the both sides, the I will be incremented. It goes like this. Fine. Now, what about the next? Now, on the left sub list, check out the left sub list. Here, 30 less than or equal to 20. So condition becomes wrong. So I stopped over there. Okay. Next, on the right side, 90 less than or equal to 80. 90 less than or equal to 80. Again, condition becomes false. So I stopped over there. Okay. So what about the next? See, about the next is, next we talk about the J, because at both sides I is been stopped incrementing. So next we have for the J, so 40 is greater than or equal to 20. So J is decremented. 40 is greater than or equal to 20. So students, J is decremented. And on the right side, we have 70 is greater than or equal to 80. So condition is wrong. So J has been stopped over there. On the right sub list, J has been stopped. So I'm just repeating the same step over below of that. Okay. So now next we have students, after decrementing J on the left side, if you can see, now my J is pointing at 10, I is at 30. Okay. So now just check it out, whether my pivot is greater than or equal to J or not. Now just check it out, whether my A of J is greater than or equal to pivot or not. So A of J becomes, on the left side, A of J becomes 10 greater than or equal to 20. Condition becomes false, so J stopped over there. On the right side, J is already stopped. So when I has been stopped, J stopped, what do you need to do? You just need to swap I and J both. So I am swapping on the left side 30 and 10, and on the right side 70 and 90. Remember, I am swapping on the left side 30 and 10, and on the right side 90 and 70. Okay, so here it is. After swapping the values, this becomes my new list. Okay, so now again start with the increment or decrement of I and J. So on the left side we have 10 less than or equal to 20, so I is incrementing. On the right side we have 70 less than or equal to 80, so I is incrementing again. Now next we have students, I is incremented, so I becomes at 30. On the right side I is at 90. Okay, so now what happens over here? See, now just check it out, the conditions for that. Okay, so what happens now? 30 less than or equal to 20, condition false, so I stop. Okay, for the left side 30 less than or equal to 20, condition stop. Okay, so that's why I has been stopped, because condition has been false. Now next we have 30 greater than or equal to 20. Yes, so J crosses I. J will be decremented. Okay. Now on the right side just check it out. 90 less than or equal to 20. 90 less than or equal to 80, condition false, so I stop. Next, 90 is greater than or equal to 80, condition true, so J is decremented. So this is my new steps. See, I crosses, repeat. See, J crosses I on the left side and the right side, both sublist. Fine. So now what to do? You need to swap. So just watch it very carefully. Here I need to swap what elements? Pivot and A of J, or we can say A of low and A of J. So A of low, on the left side we have 20 and 10. So 20 and 10 will be swapped out, and on the right side, students, on the right side 80 and 70 will be swapped out. So whenever the pivot element get its placed, that place becomes fixed. So here the 20 and 80 has been fixed at that place. So now you cannot move 20, 50 and 80. So now what you need to do is, you just need to apply the quickshot algorithm, same as the previous that we have just recently applied, on 10, then 30, 40, then 70, then 90. Okay, so you just need to apply the quickshot algorithm on these 4 parts. Apply them and check out, and you will get this answer as a sorted list. Fine. So this is our quickshot example. Now let's say about the algorithm of quickshot. So algorithm, it goes like this. Algorithm of quickshot is A of 0 to n minus 1, comma low, comma high, where low shows the lower bound of the array and high shows the higher bound of the array. First you need to check out, if my low is less than or equal to high, then m is equal to partition of A, comma low. See, this partition is another function or another algorithm which returns the position of J. Returns the position of J where you need to divide the list. Okay, here there is no middle point over there. That's why we apply the partition algorithm over there, that returns the value from which we need to divide our list. So m, or you can say mid, both are same. So mid is equal to partition of A, comma low up to high. Then apply the quickshot on low to mid minus 1 and mid plus 1 to high. Okay, so you need to apply the quickshot on the both parts, from low to mid minus 1 and mid plus 1 to high. See, I am not going to apply on mid because my mid becomes fixed over there. As we see, the 50 is fixed, and we applied the algorithm on left side of the 50 and right side of the 50. Same like that, you need to apply quickshot same like on that list. Now next we have the partition algorithm. So students, the first algorithm partition, let's see how the partition algorithm works. So students, the first algorithm partition is A of low up to high. Then we'll see the pivot arrow A of low. Okay, so first you need to apply pivot on A of low. then I is also on low, then j is on high, then while I is less than equal to j, see, while I is less than equal to j, check out whether while a of I is less than equal to pivot or not. If a of I is less than equal to pivot, just you need to increment I. If a of j is greater than equal to pivot, then decrement j. If in some cases both get stopped, okay, so what you need to do? You need to swap both of them. Okay, so swap a of I and a of j. Else, see, this is the part where I is less than equal to j. That means j does not cross I up to now. Now, after while loop, if j crosses I, then what to do? You need to swap a of low and a of j. Okay, so that's a partition algorithm. After that, at last point, you need to return j. This is the algorithm for quick short partition. Now, let's begin with the merge sort. Now students, let's start with the merge sort algorithm. See, merge sort, that means here you need to divide your partition into two sublists where we have S1 and S2 with us. Then we need to conquer the sorted list S1 and S2. After conquering both of them, we need to just merge the unique sorted group. So, how to do that? Let's see. See, just I am showing you one example, you will get a better idea for the merge sort over there. See, here we have the list with us which is unsorted, that is like 70, 20, 30, 40, then 10, 50 and 60 with us. Okay, so here my low is at 0, high is at 6. So which element or which index becomes my midpoint? 0 plus 6 by 2, that means 3. So you need to divide your whole list from 3. So your left part will become 0 to 3 and right part will become 4 to 6. So here it is. I am just dividing the list from this 40. So the left part we have 70, 20, 30 and 40. On the right we have 10, 50 and 60. So now what you need to do is you just need to again divide the part, again divide the left sub list from the midpoint. So here we have, if you can see 0, 1, 2, 3. Okay, so 0 plus 3 by 2. 0 plus 3 by 2, that becomes 1.5. So you need to divide from 1. So 0 and 1, that means 70 and 20 at the one side and 30, 40 will go on the other side. So what about the 10, 50, 60? Here we have 4, 5, 6. Indexes are 4, 5 and 6. That becomes 4 plus 6 by 2. It becomes 10. So 10 by 2 becomes 5. So you need to divide from the 5. So 10 and 50 will go on the one side and 60 on the other side. So next we have 70 and 20 as individual entity. Then 30 and 40 as individual entity. 10, 50 and 60 as individual entity. So what is our goal? Our goal is to divide the list as an individual entity. Fine. Okay, so this is a divide algorithm. In merge sort, you need to apply first divide algorithm. After dividing, what you are going to do is we are just going to conquer them. Okay. While you are conquering both lists, you are just sorting them. Okay. So conquer and sort, that is the process. Okay. So what we are going to do is when we are just merging 70 and 20 together, they are just in a sorted order. So it goes like this. See, 20 and 70. When we are merging 30, 40, both are in sorted order, 30, 40. About 10, 50, same, 10, 50 and 60 is alone. So 60 is there. Now, see, again start merging operation. So 20, 70, 30 and 40, these four elements are combined together and sorted like this, 20, 30, 40, 70. At last, we have 10, 50, 60. They all get sorted together while merging. That becomes 10, 50 and 60. And students, at last we have 10 to 70 as a sorted order. Like 10, 20, 30, 40, 50, 60 and 70. So this is how easy the merge sort works. Now, let's see how the logic begins for the merge sort. So here it is, the algorithm for the merge sort. You need to apply the merge sort algorithm for a of 0 to n minus 1 low comma high. Low shows the lower bound of array, high shows the higher bound of the list. So we have, if the low is less than or equal to high, then first you need to divide the list. So your middle point becomes mid is equal to low plus high by 2. Okay. So what you are going to do is we just need to apply the merge sort algorithm on the both of the parts. So here we have this is a recursive. See, the quick sort is also calling itself, the merge sort is also calling itself. So these functions are recursive functions. Okay, so merge sort is calling for the array A. Now my low becomes low, and the mid becomes, and my high becomes my midpoint. So I'm just applying the merge sort from low to mid, and then mid plus 1 to high, mid plus 1 to high. So I'm just applying a merge sort on the both of them, and they are just calling itself again and again until unless they becomes a single entity. Okay, or we can say until unless my low is less than high, that condition getting false, this merge sort function is calling itself again and again. After applying the merge sort, what you need to do is at last we are just combining the result. So combine them like this, combine a comma low, mid and high. You are combining the list from the mid, high and low, all 3 points. This operation is known as merging. So that's it for the merge sort algorithm. So what you need to show is, first you need to see combine algorithm, how it works. So here it is, algorithm partition, or we can say the combine. So combine algorithm, it works like this, that first we are applying the k is at low position. What is k? K is the index which we are going to use for the temporary array. Okay, you will see in the example for the better idea. Okay, so k is the index which we use for the temporary array. Then we have I is initialized at low. Then we have j which is initialized at mid plus 1. Okay, now see, if my I is less than or equal to mid and j is less than or equal to high, just focus on this condition because it is very important. Okay, if my I is less than or equal to mid and j is less than or equal to high, students, what I need to do is you need to go inside the while loop. Okay, in while loop you need to check if my a of I is less than or equal to a of j. That means a of I is minimum, a of I is smaller than a of j, value of I is smaller than value of j. So you need to increment I, put that smaller value into the temporary array. So temporary array temp of k is equal to a of I. Okay, then increment I, increment k. That's it. What about the else part? Or the next part, else part. Suppose a of j is lesser than a of I. A of j is lesser than a of I. So what you need to do is you just need to put the smaller value of a of j into temporary array. So it goes like this. Temp of k is equal to a of j, then j plus plus, k plus plus. So here it is, else part is completed and while loop is completed over here. So this loop is going on when your I is less than or equal to mid and j is less than or equal to high. So next we have another part, the algorithm is still continue. Okay, so while j is less than or equal to mid. Okay, now suppose your both condition is not satisfied, only one condition is satisfied, like while I is less than or equal to mid. Suppose students, if I is less than or equal to mid, then what you need to do is same as the previous steps, apply the smaller value a of I to temp of k, then increment I, increment k. Next, while aj is less than or equal to high, then apply a of j to temp of k, so increment j, increment k, and that's it. This is how my algorithm works. Now let's see how the example works. So students, first we have the whole list. Low is at 0, high is at 6 and mid is at 3. Okay, so what we need to do is we just need to combine, first find out the midpoint. So mid is 0 plus 6 by 2, that becomes 3. So we need to divide these steps like this, divide this list in 2 parts. So now my new low, new high, new low, new high is here, you can see. Okay, so what you need to do is you just need to again divide the list. Okay, so it divided from the 2 index, and from in the second list on the right sub list it is divided from the 5th index. So it goes like this. This is my division. After this you need to divide it. So at last point we have the individual entity like 70, 20, 30, 40, 10, 50 and 60 with us. Now it's time to combine both of them. Up to now students, we just applied the divide, or you can say the merge sort algorithm, okay, function. Now you need to start for the combining function calling. Okay, so now you need to start the call the function combine. So here it is, function calling combine, where you need to call like 70, 20, 30, 40, 10, 50 and 60. Okay, Just imagine a situation, I have just combined my list. So here 20, 70, 30, 40, 10, 50 and 60. So I have already prepared. Now what I'm going to show is, I'm just going to show the combined algorithm for 20, 70 and 30, 40. How the two lists getting combined together and they getting sorted. Let's see. First we have, see my A array is there, temporary array is there. Okay, what I need to do is, I need to apply my algorithm. Whatever the smaller values I get from the list, I just put it into the temporary array. Okay, so first we have 20, 70, 30 and 40. So what you need to do is, first you need to compare A of I and A of j. Okay, so here it is, my conditions. Okay, so if my A of I is less than or equal to A of j, is that so? See, 20 less than or equal to 30? Yes. So 20 is smaller, so you need to put 20 in temporary array, then increment I, increment k. So it goes like this. Okay, my I is at 70 now, k is incremented. Okay, so now check it again. Now A of I is less than or equal to A of j. See, 70 is less than or equal to 30? No. So go into the else part. So in else part you need to put A of j into temporary array. That's why 30 will be set on the temporary array. So 30 is go at the temporary array, then j is incremented, k is incremented. So it goes like this. Now check the conditions again, that 70 is less than or equal to 40? No. Again go to the else part. So now 40 is set down on the temporary array, then j is incremented and k is also incremented. So it goes like this. See students, after incrementing j, now my j is not less than or equal to high. My j is not less than or equal to high. So if you remember the while condition, that contains that I is less than or equal to mid and j is less than or equal to high, then you need to apply the previous if and else function. If it's not like that, then you need to go for these two while function. Okay, so my first while function is, if while I is less than or equal to mid, what I need to do is the remaining all the elements. See, my j is completed, right part is completed. So whatever the remaining elements are at on the left part, you need to put all of them into the temporary array. So my temporary array 70 will go on here. Okay, I will be incremented and k will be incremented. Fine. So this is the how we combine the two lists, or how the combined algorithm works. Okay, let me show you for this also. Okay, let's combine this 20, 30, 40, 70, 10, 50 and 60 together. Here for your convenience, I have just written all the conditions over here. Okay, so let's start with the I. See, 20 less than 10, condition false. Check out the if part. Okay, check out the if part right now. 20 less than 10, condition false. Go to the else part. What you need to do is just apply, put the value of A of j to temporary array, then increment j, increment k. I just did it. Increment j, increment k, 10 will be in temporary first position. Now 20 less than 50, condition true. So put 20 into temporary array, increment I, increment k. So here it is. Next we have 30 less than 50, condition true. So what you need to do is increment I, increment k, put 30 into temporary array. So here it is. Next we have 40 less than 50, same, increment I, increment k, put 40 into temporary array. Next we have 50 with us, 70. So 70 less than 50, the condition becomes false. So what you need to do is, now put 50 into temporary array, increment j, increment k. So here it is. Next 60, 70 less than 60, condition false, increment j, increment k, put 60 into temporary array. So here it is. Now my j is greater than high. So you need to go towards the while loop. So in while loop, again we have I less than or equal to mid. Yes, still I is less than or equal to mid. So what you need to do is, you need to just put I into temporary array, increment I, increment k. So here it is. After incrementing I and increment k, this becomes my final answer. Fine. So this is how our merge sort works. Okay. So at last position from the temporary array, you need to copy all the elements into the our actual array A. Combining the two lists, what you need to do is at last just copy the values from the temporary array to actual array A. So that's it for today's lecture, students. Thank you so much.